Not supporting it.
Just download it. Cannot? Maybe your internet issue.
It's happened like so many times. Sometimes it's work, sometimes it's
Yeah. Yeah, you cannot run the code, but hopefully you can practice about what you can write over there. Yeah, the first line should be very straightforward, which is essentially you're just comparing the string to your name, right? The MP name to your input name. For the second part, you can again referring to the install function where we freed up the existing definition, right? If it's already there, you can apply the same idea to the name, to the definition, and finally to the structure itself. All right, so let's see. The answer here. Yeah, so first of all, you use a string comparison function to compare the name and where your pointer is pointing at, right? If it's fine, then we're just going to free up everything. You freed up the name, freed up the definition, freed up the structure itself. Okay. Can anyone tell me if I can reverse the order of those three commands? Let's say can I run this first? Currently, we're
no.
up the name first, definition second, then lastly the whole structure. Can I free up this one first?
No, I think because the name is the first pointer it is pointing to.
Any thoughts?
No. Hello.
Can I move this one up before the MP name? No, no guess. Yes or no? Just make a guess. No. Okay, it's quiet. Okay. Well, the answer is no. If you freed up this one first, you cannot find those name and definition anymore. It's disappeared. Okay. Then you have spot in your memory which you cannot access until you kind of shut down your program. All right. So that is the hash table or hash map. So again, hopefully you can repeat what I just showed you here, in your interview, just in case anyone asks you about it. But again, this could be very, very sophisticated, such as like, especially when we talk about the collision. This is called collision. So when we already have a stream here in the table and we're adding another one in the same location, this is called collision. When it happens, one way is to simply use this linked list to store the rest of them. Could be the other way would be you just look for the next available location and just store it there. Okay, you can do that because you can imagine if the information are all in this table, that's the most efficient situation, right? If you used up the whole space, right? Otherwise, if you have a lot of empty space in the table, rather you are using a very, very long linked list, that's defeat the purpose of this structure. The structure is most efficient when everything is in this table. So again, there's many, many ways to resolve the collision. One way it will be linked list. The other way will be you simply just move to the next location or whatever other method is. Okay, so that could be very, very sophisticated. But just for the demonstration purpose, today we just use a linked list because we just learned the linked list. All right.
Hello, sir. Can you hear me?
Move on. The field. Okay, so the other way to use this structure is using field. Okay, the field are storing flags for a lot of cases, often to do with I/O device, hardware, such things. So let's first look at this example, which we kind of learned already. So we have defined three masks. Okay, first mask is called keyword. Second mask is called external. Last one is static. Note here, those mask value are 0 or start with 0. What does that mean? Like, why does it start with a 0? Any guess? Anyone still remember? I think that's from the second lesson, not third lesson. No? All right, so if it's start with a 0, that's binary. Okay, this should be in binary form. So this could be 0, 0, 0, 4, like 7, 0, and then followed with a 1. This one is 6, 0, and 1, 0. And this last one is 5, 0, and 1, 0, and 2, 0 afterwards, right? So this is basically flag one of the bit in the 8 bit in total, right? Okay, so that is how it works as flag, right? So if we want to set an existing bit by turning on its external bit and static bit, then we can use this symbol, basically this external or the static, right? All right, so let's just review this example again. So our keyword flag is like this, right? And external bit is and static. So this is how they'll look like. Now, if we have a random bit, okay, this is a new bit. Like this, all right? So what we want to do is we want to flag it as an external bit and is a static bit, right? This is the set bit. The set bit will do this OR operation, right? Essentially, this will become external or where's my or? Oh, here, or static, and that will become right because both those two bits are one, right? Like essentially, this third bit is flagging if it's a static or not, right? And the second bit is to flag it's a external or not, right? So this is your external or and actually and static. Then if you apply this with our new bit using the OR operation, right? This will effectively flag those second and third bit into one. All right. Again, I gave you those examples before, so I'm not going through all of them. But effectively, you can understand like having those flag or called bit mask is effectively control one of the bit at a time, right? This keyword mask will turn on or off your last bit in your existing new bit, right? If you do the OR operation, you will turn the last bit into one. Otherwise, if you want to clear that bit, means turn it off, you can use the OR operations and AND operations and reverse, right? So you can always turn it off. So so those again, each of those things are deciding one of the bit in your binary form. Okay. This was done before. Okay, we have talked about this before. Now let's talk about how to represent the same thing in the structure called field. Okay, so this is how it looks like in the field. So this is, first of all, it is called a structure, and then we name the structure as flag. Inside the structure, the type of those variables are unsigned. Okay, that means unsigned integer, right? We talked about that before. And we just assign a bit 1 to it only. Okay, this is actually clear, our personal saying, right? It's also more readable because you can simply determine what is your flag is by flags dot is external. If that's 1, means it's external. If it's 0, it means it's not, right? So again, inside the memory, it's almost doing the same thing. This way and this way. They're doing the same thing, but this is more readable. Okay. Also, as the example I showed earlier, those symbols are only, well, those three, all three of them are only occupy one byte inside your memory, which is very efficient. Okay. So it will automatically imagine the space for you. All right. So, however, if you wanted to strategically assign where the bit should go, you can also use padding. Okay, we will give you some example later. But effectively, what this do is in a memory space, let's say this is your new memory space, you have a bunch of values in your byte, right? So you effectively use one of the bytes, maybe the last one is the keyword, and second last one is external, and the third last one is static. So that's those three will be stored, will be reserved as flag as your flag structure. Okay. So now let's look at how the padding works. So if you define this way, all right. First of all, you reserve 3 spots in one binary, okay. And then you use an unnamed. See, this is empty there. Like there's nothing between the n sign and the comma. So in between, that means this is like unused space. Okay, unused space, you just don't give it a name, but you still want to reserve the spot of it. Okay. Then the second field will be you take entire A bit for a second field, and then you force it into another bit, and then finally you reserve the last 6 bits for your field 3. Yeah, field 3. Okay, let's see how that works. So let's say this is your field 1 and 2, 3. Okay. In field 1, you reserved the last 3 bits, but you leave the remaining 5 is unused. So you only use those last 3 bits here. Then the field 2, you use all of them, right? Because we say unsigned field 2 8, right? So we use all of them. I should mark them as red. And then this line is almost like enter, right? You turn to the next field, and then you reserve 6 more spots. So that would be like this. Okay, so this is how you strategically take spots as you want, because this way you can line up those 3 bits and those 3 bits. Maybe later on you will do some AND or OR operation together just to do a more sophisticated things. Just what I'm trying to explain to you is how to use this padding, right? So you assign a field with no name, right? And you assign a number of bits or even 0 just to force it into a new field, and you create this structure in this way. Okay, we don't have any exercise or further example for this one. Same as this next one is union. Okay, so sometime in your code, it is happening that you want to store a value, but the problem is you don't know what type of the value is. Sounds very odd, but it could happen. Okay, sometimes let's say the input could be either integer or floating point or even a string. Okay, while you are programming or before you run the program, you have no idea which type that is, and then it becomes tedious in your code. You could potentially initialize 3 different variables, one for storing integer, one for storing flow, one for the pointer. But the drawback of that is you're wasting the best space, because out of those 3 variables, you will only occupy one of them. You know that. So instead, in using this union structure, you can put all 3 things together, and it will only occupy one space, which is the biggest value in this structure. All right. For example, the float is maybe 16-bit versus the integer is only 8-bit. So this whole union structure will take 16 bits in total, rather than A plus 16 plus 8. It's not like that. Okay. So again, the purpose of it is just to save spots, save your memory, right? So when you're calling the value of it, is that's the same as the other structure. You can either using a dot to access the value of it, or using pointer and then using this arrow to access the member of it. Here is the example. So assuming in the previous code you are reading in a variable, and then you use your function to determine the type of it, right? And then if the type is integer, you're going to store that value into this u value I value, right? Here we use print for demonstration purpose, right? Effectively, basically, we're comparing the type of the input, and based on that, we will use different variable in your union structure. Okay. You can nest the union inside another structure, okay, or the other way around, just like nested structure itself, right? Union is effectively a structure itself. So you can do in this way. So in the previous example, we're creating a structure which already have this U type, right? And then we'll store the value into one of those based off your U type, right? So when you're calling for this value, you could effectively say, okay, dot U value dot I value, right? As an integer form. Or dot U value dot P value, which give you the pointer of your string, or the first character of your string. Again, effectively, the main reason of using that is to share the same starting address, and it saves spots. In the old C program, you can not assign union or pass it to the function, but you can now. You can do it now. That is very convenient. Okay, the last topic we're going to talk about today is the type definition. This type definition is very much like the define command we have done before. So instead, we use the type define, right? Type definition. And then we will rename existing type by a different name. Okay, so effectively, this length is a variable type now. Okay, this type is the same as this integer. That's exactly the same thing. There's no any modification of it. Okay, just like you will declare a variable called length and maximize as integer, you can use the length instead here. Or for the calling a variable, array, string array, right? So when we use that to replace a string, right? Then that become very convenient because now we can skip using this star, right? Before, if we want to create a pointer, we also always want to have this star there to create a pointer. But now, because we define this string is pointer already, then when you call creating new variable as pointer, you don't have to put a star in the front anymore, right? You just string and then the pointer A, pointer B, pointer C, something like that. Okay. So just potentially make your code cleaner, but might also make your code a little bit more confusing as well. Here's a little bit more specific example. So where we will define a structure. Okay, so in this structure, we create two alternative names for this structure. Okay, so the first alternative name is tree node. Second one is tree pointer. They are pointing at the same structure, but they give you flexibility, right? When you want to declare a pointer, then you just use tree pointer, and it will create a structure and then make a pointer pointing it. Or if you only want to get a structure itself, you use this tree node structure. So here you can see we create two new names for our structure T node at the same time in one line, right? So this way give us a flexibility. It depends on what do we want to define. If we want to define the structure, we go here. If we want to define the pointer, we go here. A few things. It's not creating any new type. It's only just a way, just as you like create a definition, create a shortcut to your existing definition. Very similar to the define, right? You can also define that for a pointer to a function, right? Remember, before we talk about pointer to a function, you have to make it very complicated. You have to do this you have to define the return type. You have to have the star. Yeah, then you have to have those two brackets, right? Now, by defining this way, you save everything. So now, if we're going to declare the pointer function, this is a function now. We simply just call it pointer function as integer and then 1, 2, 3, right? We don't have to add a bracket behind it. Okay. So the main reason here to use this type definition is because we wanted to make our code portable across the different systems. Let's say in one system, your integer is 8-bit, while the other system is 16-bit. If you define every integer in your code as int space variable abc, right? That means your code in your entire code has to be changed. Because one system is 8-bit, the other system is 16-bit. You have to make a lot of check, make sure they're not out of bound. Instead, if we use this way, we use the type define integer, then space, say my integer, okay, and the float space my float. Once we're going to port it to a different machine, we only need to change that particular line. Now we create a new definition. Now my integer is not an integer in this system anymore. It's actually a float in this system, or whatever other things is. So that means whatever the code you have wrote, you don't have to touch it. You only change the first two lines where you define where the short is, what's the integer, what's the long is. Because those three size are different between machines. That's essentially why they created this. So just to make your code be compatible across different machines as much as possible. Some might claim that it's also easier for reading, right? Assuming that you are making this name understandable, right? Then you can replace this whole thing, this whole structure T node star, right? This is less readable. You can just simply replace that with your tree pointer. Then you can create that as well. And also people creating other tool to help you actually check on the function, but then you can build your definition into those checks as well. All right, so today we have a short lecture because we only have one exercise. Let's wrap it up. So today we have talk about the linked list. Well, not today, but we talk about a few core data structure: linked list, tree, and hash map. Hash map is what we talk about today, and we use some example to show you how to look up, how to hash, and how to install. Right, and we also practice on how to use the allocate function and the free function to control the memory. Then we talk about three different definitions. One is bit fields, which store bits in a very efficient way. Union, store different type of variable in the same, so you can manage them without taking too much memory space. And lastly, type define. Type define is creating an alternative name for existing type. It may make your program be very portable if you cross the machine, or it will make you more readable if you are dealing with a bunch of structure or pointer or functions like that. All right, that's it for today, and I will see you on Thursday.
So